All right, so let's imagine for a second that we've got two light poles that are separated by 12 meters. This is my imaginative diagram here. You've got this one here that's at the origin, sort of there, and then this one's 12 meters away, and it's emitting some light. And basically what we're saying is that there's a function f of x, which is equal to b on x squared plus 1 on 12 minus x all squared. But it's in the domain between 1/2 and 23 on 2, which is 11.5. And basically, the question that we're trying to answer is for what values of B, so this is unknown at the moment, is the minimum light intensity 1/2 meter away from light 2? Okay, so the first thing we can do is just get a feel for what's going on with the question. If we make B equal to 1, this is what we'll get. And I run the risk of confusing the diagram with the graph, but I think it's quite nice in this example. So basically, if you make b 1 in this function, you're going to get this over here where you can see b is 1. This is a situation where the light coming from both light sources is equivalent. If I was to make this b value, say 4, that would mean that the light coming from light 1, which is this one here, would be 4 times as bright as this light over here. Okay, so let's just put B back to 1 for a second. So let's have a think about what's going on here. 6 would be the exact midpoint of the two lights, right? Because they're 12 meters apart. So if we actually put that point on, let's interpret this point, we've called it F, is the minimum of the function, right? So it's got an x coordinate of 6 because it's the midway between and they have equal brightness. And the brightness at that point, whatever the units are, I think brightness is measured in lumens for the physics people out there. But yeah, that's 0.06 lumens, let's say. So yeah, that's a situation where both lights are the exact same brightness. As this light gets brighter, you can see that the point of minimum brightness moves towards the right. And now that point is no longer accurate. The minimum would be somewhere further to the right now. Okay, so that's sort of what's going on. As we change that value of B, yeah, that graph clearly changes. It gets dilated. And then, so this, the question says, for what values of B is the minimum light intensity 1/2 meter away from light 2? Okay, so we need the minimum intensity to be basically here. This is at 11.5, which is why I actually think this question is not it's not asking the right question. And you'll see why in a second. So I think this question is actually a bit flawed. You'll see why. So let's think about how we would do that. If we get our calculator up for a second, what we can do is we can define the function. So let's b on x squared plus 1 on 12 minus x all squared. Okay, we won't worry about the domain for now, but we are going to define that, and let's call it f of x. Okay, what we're going to do now is we're going to do a calculation diff. I just press OK for now. We're going to take the derivative of f of x, which was our function that we defined. We need that to be 0 if it's a minimum, right? So we need to set it equal to 0 to find the minimum value, and then we want x to be equal to 11.5. So we want the x value when it's a minimum. So when the derivative is 0, that's a minimum, and we want the x value at that point to be 11.5. And then this is where it's tricky. You need to solve all of that for the variable inside f of x, which we don't know, which is actually b. So if you press OK to that, you'll get this large number here, which is why I think this question is actually not quite right. What this is saying is that this first light is 12,167 times brighter than this light. And yeah, as you can see, that's why I think the question's flawed, but nevertheless, we can still persist. So basically, if this b value is very, very large, so large that it's, 12,167, we get this situation. Again, this is the red line. The axes are completely different now, but hopefully you can see that this point here is 11.5 and it's a minimum. So if I put that point on, if it lets me, and then I actually go and label it. So if we go settings, show the name and value. Okay, you can see that there. Okay, you can see that at 11.5, that's actually a minimum now. And that's got, 96 lumens, whatever those measures represents the brightness. But yeah, you can sort of see why this is flawed. Let me just show you sort of how we got to there. So, let's make this much larger. And yeah, so basically we took this graph and we made the B value extremely large until the minimum, this point, the minimum here got to 11.5. And you can see that it needs to be much larger than even 1,000 for the minimum to get to 11.5. So yeah, hopefully sort of seeing how the question, you can work the question out, but realistically, I don't think that is what the question was trying to get across. So hopefully that clarifies things.